Welcome everyone to this math webinar to review the top most frequently tested questions that come up in the arithmetic theme of math questions on the SAT and ACT. So this math review is going to focus on mean and median, percents, and probability, which again are those top three most frequently tested arithmetic question types. I'm also going to throw in one question on vectors and one on matrices. Those concepts are super rare, super random, but I just wanted to do one of each so that you can get a quick exposure to those concepts. I'm excited to go through this with you, and let's go ahead and get started with mean and median. For the mean and median questions we're going to go through together, we're going to do 3 of them, and they're going to advance from kind of medium level difficulty to hard. So let's go ahead and start. It says that Andre's Floral Shop asked each of 25 customers, so we're going to have 25 people, to give a rating of the shop's service. The table below summarizes the 25 customer ratings. Okay, so it looks like we have 7 people who gave it a score of 3, 10 who scored a 2, 3 who scored a 1, and 5 who scored a 0. Which of the following is closest to the mean of the 25 customer ratings? So the first thing I want to make sure that you know, because it's the most common mistake people make, is to find the average of the customer ratings. They do 3 plus 2 plus 1 plus 0 and then divide by 4 because there are 4 categories. You do not want to do that. Remember, we have 25 people who gave a rating, which means we're going to have to add 25 ratings together and then divide by the 25 people who gave those ratings. So if you think about it, we basically have to do something like 3 plus 3 plus 3, right? Basically 7 times. How many have I written so far? 6 plus 7 3s, and then we would have to add 10 2s, right? This turns into a lot of work, basically adding all those numbers up on top and then dividing by 25. But what I want to show you is a faster way to do that. So if you think about it, basically we have 7 people who gave a 3, plus 10 people who gave a 2. So right, if we multiply that together, if 7 people scored a 3, 7 times 3 is 21. We're going to have 21 total rating points from those 7 people. If 10 people scored a 2, when you multiply those together and get 20, that means we have 20 total rating points that came from the 10 people who scored a 2. Plus, we had 3 people who scored a 1 and 5 people who scored a 0. All divided by the 25 people who participated. So what is our next step? 7 times 3, we have 21, plus 20, plus 3, plus 0, all divided by 25. That's 44 on top divided by 25 on the bottom, which is 1.76. The question says which one is closest. So 1.76 is closest to which answer choice, and it's closest to A, which is 1.8. Our next question is asking us for median. So remember, median means it's the number in the middle. So we want to know what is the number in the middle for the given lengths in minutes of the 10 films released before 1972. So here we have a film released in 1972 and after 1972. So clearly we're not going to use those. Plus we don't even have the answer for the length in minutes for those. So that's why this question isn't including them. All right, so we have the 10 films from here to here, and we want to know the median of their length in minutes. Now, don't just jump to find the number in the middle right now. Remember, the key first step when you're solving for median is you have to put the numbers in increasing order first. So from smallest to biggest. So it looks like 99 is our smallest number. Then 105, so I'm going to cross them out as I write them down. Then 109, then it looks like 119, then 120, then 128. Sorry, thanks for bearing with me here. We have another 128, then we have 130, then we have 136, and then we have 143. So again, to find the median, I've rewritten these numbers from smallest to biggest. Now what I want you to do is remember that when you're finding the median, you're finding the one in the middle. So if I get rid of my smallest number and my biggest number, right, I'm basically going to trim the edges until I get to the center. Get rid of them in a pair, a small and a big. A small and a big, a small and a big. Well, guess what? Because we had an even number in our set, now we're left with these two numbers in the middle, right? If we had an odd number in our set, like pretend our set went 5, 7, 8, when you get rid of the smallest and the biggest, boom, your median is right there in the middle. It's easier when you have an odd number. But when you have an even number in your set, when you're left with these two in the middle, remember that what we do now is we have to find the average of those two numbers left in the middle. So how do we find the average? Well, we just did this in the prior question. Remember, we're going to add them together. So 120 plus 128. And then divide by the number of numbers, right, we added together, which we added two numbers together. So that turns into 248 divided by 2, which is 124. So that means that the median of these 10 numbers is 124. And the key initial step here is don't forget to find the median. You have to put them in order from smallest to biggest. All right, so for this last question, it's another mean question. It's another average question. And I just want you to know that this question is the hardest one, right? So we're kind of increasing in level of difficulty, but you're going to notice that this average question is going to be harder than the first one we did. Okay, so we have two sections of Algebra 1 taught at a local high school. The average score on the final exam for the 25 students in the first section was 76. Okay, so we have 25 people who have an average score of 76. Then we have the average score on the final exam for the 20 students in the second section. Okay, so then we have a class that has 20 people where the average is 90.4. What was the average of the final exam scores of the students in Algebra 1? So basically what we're going to have to do is find what is the average if we take the 25 people and the 20 people and we add them all together. Now remember that if you want to find the average is equal to the sum divided by n, right? The number of units that go into the sum. So think about it then another way is if you're dividing by n, a way to simplify this equation would be to multiply by n on both sides. So you can see then that the average times however many people went into calculating that average is equal to the sum or the total number of points when you add all their points together. So if we want to find the overall average for this class, we need to know what's the total number of points. If we add up all the points for the 25 people and all the points for the 20 people, we're then going to divide by the total number of people, which is 45 people. So how are we going to do that? Well, we're going to use this equation that I just showed you over here, which is that the sum is the same thing as the average times n, right? The average times the number of people from whom that average was calculated. So again, for us to find the overall average for the class, we're going to need to know the total number of points from everybody divided by the 45 total people. So the total number of points from everybody, remember the sum. So if we look at the first period and we want to know what's the total number of points that came from those 25 students, remember that's the same thing as taking the average and multiplying by those 25 students. So the total number of points from the first section is going to be the average of 76 times the 25 people who calculated that average. Plus, from our second section, we had an average of 90.4 times the 20 people who calculated that average, divided by the total number of people, which remember was 25 in the first section plus 20 in the second section. So we end up with 1,900 points total coming from our first section and 1,808 total points coming from our second section, divided by 45 total people. And we get that the average for the entire, or both classes, let's say, the average for the students in Algebra 1, which is in the first section and the second section, is 82.4. So the answer is C. Questions, we're going to do 4 together, and they're going to progress from an easy question to 2 medium questions to a hard question. It was actually the hardest question on a test, on a real test. So let's go ahead and begin. It says for percents, A coat has a regular price of $49.95 before taxes. It goes on sale at 20% off, right? 20% below the regular price. Before taxes are added, what is the sale price of the coat? All right, so here's how I want you to think about this. If we represent this bar here is 100% of the cost of the coat. Remember that the cost of the coat is $49.95. But we want a discount, right? We want to take away, we want to subtract 20% of that cost. So what I want you to do, because again, I know we go over this a lot in the Winward Academy percents lesson. So if you need a refresher, please make sure you refer to there. Taking away 20% of something is the same thing as keeping 80%. So the way that some students approach this is they find 20% of $49.95, and then they take that value and they subtract it from $49.95. So you'll notice that takes 2 steps. What I'm showing you here is a way to solve this question with 1 step. So again, we're just making it a bit more efficient. So what I want you to remember is taking away 20% is the same thing as keeping 80%. So our sale price right here, which we get after we take away 20%, we're just going to calculate by finding what is 80% of $49.95. So I'm going to write that out for us. So it says, what is 80% of $49.95? Now, in our percents lesson on Winward Academy, we go over a super great trick for how do we convert from a sentence like this to an actual math equation. So remember, when you see a what, you put an X. When you see is, you do an equal sign. 80, you just write 80. Percent, remember when you see percent, you do divided by 100. Of is the same thing as times, and then once again we have a number, so we just write the number. So what we have just done, I'm going to refresh for a second, we're doing a 20% discount. A 20% discount is the same thing as keeping 80%. It would be the same thing. A 30% discount would be keeping 70%. A 40% discount would be keeping 60%, right? These add up to 100%, which is the original price. Once we know that we're going to calculate what is 80% of $49.95, now we can just solve. So x equals 80 over 100 is the same thing as 0.8 times $49.95. So the answer for the sale price before taxes is $39.96, which is option C. All right, now we have another question where we get to practice applying our conversions from a word or from sentences like what is 4% of a number. We're going to convert that just how we did in the last question. So when you see a what, you put an X. When you see an is, you put an equal sign. 4%, remember percent just means divided by 100. Of means times. And now we're going to write out this number, 6.13 times 10 to the power of 5. All right, so let's go through and convert. We have x equals 4%, 4 divided by 100 is 0.04, times, and I'm going to put 6.13. And now what I'm going to do is I'm going to multiply by 10 to the power of 5, which just means to take this decimal place and move it 5 places to the right. If it was 10 to the power of -5, we would go 5 places to the left. Because it's 10 to the power of 5, we're going to go 5 places to the right. So here's 1, 2, 3, 4, 5. So our new decimal place goes here, and then you'll notice we're going to need to fill in a 0 there, a 0 there, and a 0 there. So really what we're doing to calculate this is we're doing 0.04 times 613,000. That answer is 24,520. So our answer is B. Next question, also a median. My brain went to median, but I meant to say medium. So for percents, this is also a medium level of difficulty question. Not a median question, a medium question. So here we go. Recently, a director made a new version of Vertigo. So here's Vertigo right here. Here's the year. Here's the length of time. The new version is 18% shorter in length than Hitchcock's version. And remember, this table is showing us the length of the Hitchcock version. Which of the following is closest to the length in minutes of the new version that is 18% shorter? So we're going to do this one the exact same way we did the first one about the $49.95 with the 20% discount. What we have here is that 100% of the length of Hitchcock's version is 128 minutes. But we want to make it 18% shorter. So if we want to take away 18%, that's the same thing as keeping 82%. So really all we want to do here is find what is 82% of 128. Yes, you could find 18% of 128, take that number and then subtract it from 128. But what I'm trying to do is show you how to save a step. Taking away 18% is the same thing as keeping 82%. So we want to find what is 82% of 128. What is an x is an equals. 82% is 82 over 100. Of is times 128. 82 over 100 is the same thing as 0.82. 0.82 times 128 is 104.96. It says which one is closest to that length, so we're going to have to round our answer, and 104.96 is closest to 105. All right, so for our last percent question, this one is hard. And so again, we're going to kind of see that we're doing the same steps, but something about the numbers or something about what the question asks us is going to be a little bit trickier. So this one tells us that a shirt has a sale price of $32.80, which is 18% off the original. Okay, I'm going to pause for a second and I'm going to draw this out just how we've done the others. When I took away 18%, remember, we started with the original price up here, but we don't know what that original price is. When I take away 18% from that original price, my new sale price is $32.80. Okay, so let's think about this another way. When I kept 82% of the original, it was $32.80. Said the same exact way, when I took away 18%, the price was $32.80. So we want to know how much less than the original price is the sale price. Well, for us to know the difference between the original price and the sale price, we need to first know what is the original price. So what do we know? We know that $32.80 is 82% of the original price. Okay, so the reason this question is harder than the ones we did before is that with the ones we did before, I'm going to just go back for a second, we started with the original, took away 18%, and then our goal was to figure out what number goes here. What we're doing now in this question is we're doing the reverse. We're starting with the sale price or starting with the reduced price and working backwards to get to the original. So when you think about this question, again, it's harder because you're going the reverse direction, but our steps are the same, and that's what I'm hoping that you see. So we know that 32.8 is, we do an equal sign, 82% turns into 82 over 100, of is times, and it's 82% of what, right? Of what is the price of the original. So I'm just going to do an X. You could do an O if you want to use an O to kind of symbolize original. I just was avoiding that because an O could look like a 0, and I prefer to just always solve with X as the missing variable. Okay, so we have that 32.8 equals 0.82 times X. To solve for X, because we're multiplying by 0.82, I'm going to divide by 0.82 on both sides, and I get that 32.8 divided by 0.82 is 40, so 40 equals X. I now know that my original price was $40. Well, if I know that my original was 40 and my sale price was 32.8, the question is how much less than the original price is the sale price? So to find the difference, I'm going to do $40 minus $32.80, which yes, of course, you can use the calculator. $7.20 is our answer. That is the difference. So our answer is D. So for the probability segment, we are going to do 8 questions together. Now I know that that's a lot more than the number of questions we did for some of the other sections and categories. The reason we're doing this many is that probability is tested so heavily, and in going back through real exams from the past year, there were so many questions on probability, and there were little nuances in the questions, so I just wanted to make sure that we do enough examples so that you have a solid understanding and you see subtle ways that they can change what they're asking, but at the end of the day, you're really being asked to do the same thing, which is find what you want divided by the total possible, right? That's what probability is. So let's go ahead and get started. It says a bag contains exactly 18 solid colored buttons. 4 red, notice I'm going to take notes as we read. 4 red, 6 blue, and 8 white. What is the probability of randomly selecting one button that is not white? So the first thing I want to make sure that you remember is that the definition of probability is that you're finding the number that you want divided by the total possible number in the set. So let's use that equation, right, or use that knowledge to solve this question. Well, how many satisfy what we want? We want not white. So not white would basically be red or blue. So how many total buttons, how many total buttons are not white? Well, we have a total of 10 that are not white, right, because they're red or blue. Over how many total buttons do we have? We have 18 total buttons. So the answer to this question is that we have 10 that satisfy what we want as being not white, divided by 18 total. To simplify this down, I'm going to divide by 2 on the top and the bottom. So my simplified form of this fraction is 5 on top and 9 on the bottom. So the correct answer is C. Here's our next probability question. And notice, a long word problem. So I'm going to take notes as I read. If it rains in San Diego on a particular day, the probability that it will rain there the following day is 0.6. So I'm going to put a note to myself. The probability that it will rain after a day of rain equals 0.6. If it does not rain in San Diego on a particular day, the probability that it will rain the following day is 0.05. So the probability of rain after no rain is 0.05. Given that it rained in San Diego on Tuesday, so I'm going to put a little line for myself. So on Tuesday, it rained. We want to know what is the probability that it will not rain on Wednesday. So here for Wednesday, I want to know what is the probability of no rain on Wednesday, given that it rained the day before. So the first thing I'm going to do is I need to make sure that you know that we're not going to use this equation or this probability. And the reason is that that second conditional probability that they gave to us, the probability that it rains after no rain, doesn't apply to this question, because this question is basically asking us what's the probability that it does not rain after it rains. But this probability here was the probability after it does not rain. So that's not what we're looking for, right? We're looking for the probability after it rains, not the probability after it doesn't rain. So what I know is that given that it rains on Tuesday, the probability of rain the next day on Wednesday is 0.6. But I don't want to know the probability of rain. I want to know the probability of no rain. So what you have to know is that if they tell you that the probability that it rains is 0.6, the probability of no rain is calculated as 1 minus 0.6, which is 0.4. So the correct answer to this question is B. And again, the key takeaway here is that if they give you some sort of probability, like the probability that Jennifer's going to win is 80%, is 0.8. Well, that means the probability of no win, right? The probability of the opposite condition, the probability of losing, would be 1 minus 0.8. Same thing, if I say that the probability that someone is happy is 90%, is 0.9, the probability that person is not happy is 1 minus 0.9. So the key takeaway from this question that I want to make sure that you know is that if you're calculating the probability of not something that they've given to you, you need to do 1 minus the probability of that something, whatever they've given to you. All right, let's do our next question on probability. A bag contains 10 solid colored marbles of the same size. Okay, so we have 4 red, 1 green, 2 yellow, and 3 blue. Which of the following expressions gives the probability of drawing at random and without replacement? That means if I stick my hand in the bag and pull a marble out, I don't put the marble back before I do my second draw. After I do my second draw, I do not put the marble back before I do my third draw. Okay, so without replacement means when you take something out of the bag, you do not put it back in. You keep it out. So we want to know what's the probability of drawing at random without replacement that the first one is red, the second one is yellow, and the third one is red again. So let's go through one at a time. What's the probability of red on my first draw? Remember, probability is defined as the number that you want divided by the total possible number. So how many are red? What I want in the first draw is 4 that are red divided by there are 10 total marbles, right? If I add up 4 plus 1 plus 2 plus 3, I have 10 total. So the probability for my first draw of getting red is 4 out of 10. Now we have to be careful because I've now taken a red away. So instead of 4 reds, I have 3. Instead of 10 total, I have 9 total. All right, so now let's do what's our probability of yellow. Well, what I want is the 2 that are yellow out of the total possible number of marbles, which remember is now 9 because I took one out on my first draw. So now the next thing I want to do is mark that now I don't have 2 yellow anymore. I'm down to 1 yellow. Instead of 9 total in the bag, I now have 8 in the bag. Now let's do our last one. What's the probability of getting a red? Well, I'm down to 3 reds over how many total are in the bag? 8. And if I want to know the probability of red on the first and yellow on the second and red on the third, so we basically have little ands in between each of these. Remember that with probability, when you see an and, I want you to multiply. So I'm going to do 4 over 10 times, 2 over 9 times 3 over 8. So it looks like the correct answer is D. Let me just double check. 4 over 10 times 2 over 9 times 3 over 8. So key takeaways from here. Remember, probability is defined as what you want over the total possible. And anytime you want to know the probability of something and something and something, you're going to multiply between each one. A science teacher recorded the scores in points that her students earned on their final exam. The scores of each of the students are represented in the stem and leaf plot below. So this is great. We're going to get to review a stem and leaf plot. What is the probability that a student chosen at random from the class will have earned at least 70 points on the final exam? Okay, the first thing that you need to know is that if I say at least 70 points, that means somebody who got a 70, a 71, a 72, etc., any number from 70 or higher. If you need to be at least 16 years old to drive a car, then you're allowed to drive when you're 16. If you need to be at least 21 years old to drink alcohol, you have to be 21 or older. So the key mistake that students make is they see at least 70 and then they don't count 70. They start counting with 71 and 72. So when you see at least 70, please know that you are supposed to include 70. So if we're looking at the probability that someone we choose from the class earns at least a 70 on the final, that probability is going to be what we want divided by the total possible, right? Our same equation for probability. That's going to be the number of students with a 70 or higher on the exam divided by the total number of students. So now we get to look at our stem and leaf plot. And I want to make sure that you remember here that in this stem and leaf plot, basically what they're telling us is that a 6 on the left and a 2 on the right represent 62 points. So right here would basically be a score of 62. If we did the 6 and the 4, that would be a score of 64. The 6 and the 5 would be a score of 65, etc. So if we want to know how many have a 70 or higher, let's count how many are at that 70 or above. Looks like we have one person who got a 70, a 71, 72, 75, 77, 80, 81, and 86. So the total number of people I just basically circled in purple or counted, we had 5 here and 3 here, which gives us 8 total people who got a 70 or higher. Out of the total possible number of people, let's see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, plus those 8 that we already counted is 19 total people. So 8 people out of 19 total are scoring a 70 or higher, so the correct answer is E. Really quickly, I want to make sure you know why D is incorrect. D is incorrect for people who only count 7 at least 70 points. So this is for people who forget to include 70. They think at least 70 and then they start counting at 71. Instead of seeing at least 70 and starting counting at 70, they forget to include 70. All right, so we're halfway through probability. We have 4 more. Next question. The probability that event A will occur is 0.2. So the probability, oops, I didn't mean to write an E. The probability of event A is 0.2. The probability of event B is 0.4. Given that events A and B are mutually exclusive, what is the probability of event A or event B? So all we have to do here is remember, so probability of event A was 0.2 and probability of event B was 0.4. When you see an or in a probability question, you have to know that or is the same thing as plus. Just how earlier we talked about how and was the same thing as multiply, or is the same thing as plus. So all I need to do is change that or to a plus sign. And my final answer is simply 0.2 plus 0.4, which is 0.6. So the correct answer is E. Now for our next question, it's basically almost identical, except it's an and probability instead of an or probability. So what does this question say? This one says the probability of event A is 0.2. The probability of event B is 0.4. Given that the events are mutually exclusive, what is the probability that both will occur? That is, what is the probability of A and B? So I want to know what's the probability of event A and event B happening. Well, probability of event A was 0.2. Probability of event B was 0.4. And as we reviewed earlier, when you see an and, that is the same thing as multiply. So to solve this question, all I have to do is 0.2 times 0.4, which is 0.08. And my correct answer is A. So again, just to make sure you understand before we move on, when you see an or, we turn that into a plus sign with probability. When we saw an and, we turn that into a multiply. Next question, 2 more. Tavisha owns all 12 films listed. She will randomly select one of them to view this weekend. What is the probability that she will choose a film that has only one word in its title, given that the film she chooses will have a release date after 1961? So the first thing I'm going to do is check the year of release, and I notice that they're going in increasing order from smallest to biggest. So if I only want the ones after 1961, I'm basically just going to ignore all of these movies that came out earlier. So remember, probability of something happening is just what we want, the number that we want, divided by the total possible number. So what do we want? We want to know the number of movies that have one word for their title, divided by the total number of movies that came out after 1961. All right, well, how many have a one-word title? Looks like we have 1, 2, 3, over how many total movies were released after 1961? 6. So our correct answer is A. Last question on probability. Hardest one by far. Axel is in Miss May's class. To choose 4 students from her class of 24 students to answer questions, Miss May will put 24 cards, each with the name of a different student from her class on it, in a box. Okay, so we're going to have a box with 24 cards. Each card has the name of a student. Next, Miss May will randomly draw 4 cards from the box without replacing any of the cards. So she's going to stick her hand in, pull a card out, not put that card back. Put her hand in, pull a card out, not put that one back either. Put it in a 3rd time, put it in the 4th time. What is the probability that Axel's card will not be drawn? Okay, so here we go. She's going to draw 4 times, Miss May is. So she's going to have 1, 2, 3, 4 times that she draws the cards. And remember, it's the first card and the second and the third and the fourth. So we're going to be multiplying between each one. I want to know what's the probability of not Axel, not Axel again, not Axel the 3rd time, and not Axel the 4th time. Remember, probability is simply the number that we want, which is not Axel, divided by the total number of students. So on my first draw, there are 24 students total in the class. 23 of them would be what we want because 23 of them are not Axel. Now be careful because for our second draw, we didn't put that card back in, right? We kept it out, which means now on our second draw, there were only 23 cards total. And now there are going to be 22 out of those 23 students who are not Axel. On our third draw, we only have 22 students left, right? So 22 cards are going to be left in the bag, or in the box, 21 of them are not Axel. For our last time, we have 21 cards to choose from. 20 of them are not Axel. So our final step here is to simplify. And because we're multiplying these fractions, remember if you have the same number on the top and the bottom, you can simplify. So I had 23 on top and bottom, 22 top and bottom, 21 top and bottom. So now when I multiply across, I have a 20 on top and a 24 on the bottom. Now that's not an answer choice because we need to simplify further. So I'm going to divide the top and the bottom both by 4 to simplify the fraction. And I get 20 divided by 4 is 5 on top. 24 divided by 4 is 6 on the bottom. So the probability that this teacher, oh sorry, I totally just drew over the 5 over 6. There we go. The probability that this teacher pulls 4 cards in a row, right? And that each time she's not putting the card back, the probability of not Axel and not Axel again and not Axel again and not Axel again, right? Those 4 times we had to go through and for each one write out the probabilities. And then because we wanted the situations to be the first one and the second condition and the third and the fourth, we multiplied them together and then simplified. So again, when you think about probability, it's always defined as the same thing, right? What you want over the total possible. But by going through each of these questions, we were able to go over nuanced ways that they make it harder, right? We talked about how the probability of something is 0.3, so the probability of not that condition would be 1 minus 0.3. We talked about how the probability of A or B, the or means you add. We talked about how the probability of A and B, the and means you multiply. So again, probability is not super hard. It's a quote-unquote easy equation of just what you want divided by the total possible. But what I'm hoping is that by going through several of these questions of increasing level of difficulty, that you're able to see that a probability question can be challenging, right? So if you know the rules and know how to apply them, the goal, of course, is that it becomes much more simple. For this segment on rare and random concepts, we're going to do one example from matrices, one example from vectors. Again, these concepts are rarely tested on the SAT or on the ACT, but I just wanted to expose you to kind of one of each so that if you see a question like this, hopefully you'll have a sense of how to solve. So here we go. For this question on matrices, we're being asked to do matrix A minus matrix B. Now, a lot of students will look at this and kind of freeze because they're like, oh my gosh, I've never seen matrices before. I don't know how to subtract matrices. If you are asked to add or subtract a matrix, or add or subtract matrices, it's actually pretty simple. So what you do is basically look at how we have these 4 quadrants for each matrix, right? They're both 2 by 2. So what you're going to do is in the upper left quadrant, you're going to do the number from matrix A, 4, minus the number in the upper left from matrix B. Then you're going to do upper right minus upper right. So that's just -6 minus 7. Lower left minus lower left is -3 minus 2. Lower right minus lower right is 8 minus 6. So if this question had asked us to do matrix A plus matrix B, then those numbers just would have been 4 plus the -6, or -6 plus 7, or -3 plus 2, or 8 plus 6, right? So whatever number, I'm going to color code this for you, or whatever expression you're supposed to do, like subtract, that's why we are subtracting these numbers here. If we had been asked to add, if that purple I just colored was a plus, then those purples would have been pluses. Again, so we just want to basically pull the numbers from their respective quadrants and then combine. So what do we end up with? Well, 4 minus -6 turns into 4 plus 6. Remember, anytime you minus a negative, you turn it into a plus. 4 plus 6 is 10. -6 minus 7 is -13. -3 minus 2 is -5, and 8 minus 6 is 2. So now we go to our answer choices. Which one has 10, -13, -5, and 2? And the answer is E. Now, if you're being asked to multiply matrices, what I recommend you do is on Winward Academy, we have a lesson on how to use your TI-84 calculator to help you solve questions with a lot of good tricks using the calculator. Please make sure you reference that lesson if you need a little refresher on multiplying matrices. Okay, for this last one, we're going to do vectors. So the first thing I'm going to do is kind of redraw our quadrant, or our coordinate plane, redraw our quadrants in the coordinate plane. And now I'm going to show you how do we combine vectors. Because we want to do vector U plus vector V minus vector W. How in the world do you do that? Well, what you have to remember is when you're combining vectors, I want you to think tip to tail. Anytime you combine vectors, tip to tail. So here we go. When we want to start with vector U, I'm going to start from the same point and just draw vector U. So over here, I'm going to take this and I'm going to draw vector U. So here's vector U. Then I'm going to add vector V. And remember, when you add vector V, you add vectors tip to tail. So vector V looks like this, right? It's our purple one. So what I'm going to do is I'm going to go to the end of vector U, and that's where I'm going to then add vector V, where I've basically drawn it the same length with the same orientation. So I've basically taken vector U and combined it to vector V by combining tip to tail. So the tip of vector U was added to the tail of vector V. Now for our last one, we're going to now subtract vector W. So the first thing I want to make sure that you know is that if we had been asked to add vector W, notice vector W has that length and orientation. So if we had been asked to add vector W, From the tip of vector v, the tail of vector w, if we'd been asked to add it, it would have gone this direction, right? This would have been adding vector w. But we're being asked to subtract vector w, which means that you have to take the vector and draw it the opposite direction. So that was minus w. So then our final vector, when we do u plus v minus w, you go from the same starting point to the same end point and then connect. So what is the general direction when we had vector u plus vector v minus vector w? We're basically going up and to the left. So the correct answer is B. So the key thing here with combining vectors is that you always want to combine them tip to tail, and that you want to be very careful. If you're adding them, you're going to draw them in the same way that they're drawn. If you're subtracting them, you have to make sure that you draw it the opposite direction. Okay, so that concludes our math webinar on these key arithmetic concepts that come up on the SAT and ACT. So we got a great review of mean and median, percents, lots of digging in with probability, and then a little taste of two rare and random concepts, vectors and matrices, which rarely come up. I sincerely hope that you're feeling much more confident about each of these lessons. Remember that the goal here was just to kind of expose you to a couple of each so that you could reflect on, wow, am I really confident in this, or do I need more review in this? And of course, if you need more review, then please go to Winward Academy, go to the lesson you need, whether it's percents or probability, etc., and dig in, do more lessons, do more practice questions, make sure that you're really growing in your confidence and your knowledge of each of these concepts. And good luck with your studying.